The idea is that we have already created a video on our channel. So when I'll be writing down timestamps in the description against each topic, I would also put the link in the description to that video so that you can go and take a look at that video and you can understand users and groups in a better way, okay, because I have explained in detail there. Okay, so the idea is that each user has a unique login name and an associated numeric user ID. Okay, so users can belong to one or more groups, each of which also has a unique name and an associated numeric identifier. All right, the primary purpose of these identifiers is to establish ownership for various system resources, for example, files, directories, etc. And obviously, the permissions for accessing those resources, files, and directories, and it could be any software as well. Okay, a user's name and ID are defined in the /etc slash password file. Okay, so which also contains other information about the user. A user's group membership are defined by the fields in the /etc slash password and /etc slash group files. Okay, let me write down here. All right, so a further file /etc slash shadow, let me write here shadow. So this is the file which can be read only by privileged processes and is used to separate the sensitive passwords information from the publicly available user information in /etc/password. Okay, so the various library functions are provided for retrieving information from each of these files. Okay, so there are several functions discussed in the books. The only function that we are going to discuss here is the crypt function. Okay, so the crypt function basically encrypts a password in the same manner as a standard login program, which is useful for programs that need to authenticate users. So if we talk about the general syntax of the crypt function, that is something like this. So first of all, you have to include a header file named as unistd.h. okay, so this is the header file that you have to have if you want to use the crypt function. And then the general syntax of the crypt function would be something like this, that in here as the first argument you're gonna have key, which is basically a password, and then you're gonna have the salt. Okay, constant character steric salt. Okay, so on error it would return null, and if it returns the pointer to statically allocated string containing encrypted password, that means it is a success. So the crypt algorithm, it takes a key, which is a password of up to 8 characters, and applies a variation of the data encryption standard algorithm to it. Okay, so the salt argument is a 2-character string whose value is used to vary the algorithm. Okay, a technique designed to make it more difficult to crack the encrypted password. The function returns a pointer to a statically allocated 13-character string that is the encrypted password. So in easy words, you can say that crypt basically it one way hashes the text. Okay, so that is a simple definition in simple words, in just one sentence. Okay, so the next topic is time functions. Okay, so when we talk about time, there are two kinds of time in system. One is real time and the other one is process time. So what we're gonna do is that we're gonna discuss real time and then the process time, and then we'd do an example which would cover both real time and the process time. First we'd take the real time and then we'd basically divide it to get the process time. Okay, so let's go ahead and let's discuss real time. So what is real time? So real time corresponds to the everyday definition of time. When real time is measured from some standard point, we refer to it as calendar time, by contrast with elapsed time, which is measured from some point, usually the start in the life of a process. Okay, so when we talk about process time is the amount of CPU time used by a process and is divided into user and system components. So various system calls enable us to get and set the system clock value, and that is obviously the calendar time, and a range of library functions which allow conversions between calendar time and other time formats, including broken down time and human readable character strings. Okay, so describing such conversions took us into a discussion of locales and internationalization and stuff like that. Okay, so now let's go ahead and let's try to do some real life example in which we would basically figure out the process time of the function that we would basically write inside our C. Okay, so this would probably be the first function ever written in C on this channel as well. So we'll just go here and we'd open up this file, and let me just remove everything that we have inside this main block, because we are gonna need main block anyway. Okay, so the other thing that I'm gonna do is that we would just need this stdio.h, and in here we need to use this time header file. This is the time function, the built-in header file, you can say, which contains all the time related functions. Okay, so we would call those built-in functions in this program shortly. Okay, so first of all we need to create a function, and of void type. When I write here void, it means that this function is not going to return any value. Okay, so if there would have been written an integer, float, double, or string, it would have meant that this function must return a value. Okay, so this void represents that this function needs not to return any value. So we'll just write here the function name. We'll write here func name, and basically we'll just go here and we try to write something. So first of all we print here, as we are going to calculate the time of this function name, so we just say here function starts. Okay, so it means that function has been started executed. So it means that function has been started and it has started executing this function. So the next thing that we are going to do is that we are going to run this function until and unless user presses some key. Okay, so we say that yeah, press any key, or press, let's say, press return or enter to stop function. Okay, and then obviously I give /n, which represents the next line. Okay, it would go to the next line, the out. And now I could write here a for loop, something like this, which represents the infinite for loop. And inside of that, what I would do, that I would write here, let me just go here. Inside of that, I would write here if user press any character, okay, then in fact I can write here press any key to stop function. Okay, so if get character, and if it is true, then obviously we'll write here break. So remember that if the if condition contains only one line, then you need not to put curly braces. Even if you write anything in one line without curly braces, it would consider it the part of the if statement. Okay, so after that, once we are done with this for loop, we'd come out and we'd write here printf, and we'd write inside we would write function ends. Okay, so yeah, that's pretty much it. So we put slash n for the output to go to the next line, and then we put a semicolon here. So we are done. So now we have created the function. So now what we can do is that we can also call this function inside the inside the main function. Okay, so until and unless we won't call this function inside the main function using its name, this function would not be executed. Okay, because it won't be the part of the main function. So every function, in order to execute that function, you have to call it in the main, otherwise it is useless. So inside this main, we'd write here clock underscore t, which is a built-in kind of function or class, you can say. So write here t. In C you don't have classes, in Java you have classes. So a clock underscore t is a kind of data type. Okay, so it's we are using it as a data type. So then we write here t equals, and then we basically call the built-in function, which is clock. Okay, so after that, and clock is basically, it is related to the real time. Okay, whatever it is on the available on your computer system. Okay, so that is the real time, and in order to calculate the processing time of this function, we are just going to call this function name. Okay, and after that, what we are going to do is that we're going to write here t equals, we call this clock function, and then we minus t. Okay, so what this line is doing, that basically it is, first of all, it is taking the real time on the system, and then it is basically calling the function name. Okay, and once it calls the function name, after that basically it calculates the time again. Okay, so for example, at the real time, let's say it's 8:15. Okay, and for example, let's say when it calls the function, now the time is, let's say, 8:16 or 8:17. So what's going to happen, that it is going to subtract this 8:17 minus 8:15 t, which has this value, and what it's gonna do, that the value of t is now will be 2 minutes. Okay, so that's too long, I know, that is not possible. So the value of the execution of this function would be in seconds. Okay, so now let's go ahead and let's do the other stuff. So now let's try to convert the time in seconds. So what we would do, we would write here a double variable, because it also contains seconds. So we'd write here double, then we write here time taken by function, and then we put an equal sign here, and then inside here we just put in here the typecasting. We write here double. So basically this is a kind of a typecasting. So typecasting means that you're basically changing the data type of the variable at the spot. Okay, so then you write here slash, and then you write here clocks per second. Okay, then you put a semicolon here, and after that what you're going to do is that you are going to print. Okay, so you write here print f, and inside here you write here the processing time of function is, and then you put here percentage f sign. Okay, and then after that you write here the variable name, which is time taken by function. Okay, so yeah, that's pretty much it. We are done. So now what we're going to do is that we're going to save it, c program.c, and then we write here -o, and then tst. We hit enter, and you can see that it has not given us any errors. Okay, So now would write here the binary file, we hit enter, and it says function starts, and press any key to stop function. So we press any key to stop function, and you can see